All right, let's play Cosmic Detective for a minute. We're going to open the biggest case file of all time on the most fundamental question you can ask. Why are we here? I mean, why is there anything at all? A universe packed with stars and planets and, well, us, instead of just nothing. The answer, it turns out, is buried in the evidence from a cosmic crime scene that's as old as time itself.
So here's the thing. According to everything we think we know about physics, the Big Bang should have been a cosmic flop. It should have created a universe that instantly wiped itself out, leaving nothing behind but a boring haze of energy. But it didn't. You, sitting there right now, are living, breathing proof that something doesn't add up. So, what went wrong? Or maybe, what went right?
Our investigation starts with a prime suspect, a mysterious character that completely vanished from the scene of the crime just moments after the universe was born. Yeah, we're talking about the very strange case of the missing antimatter.
Okay, so you've got two main characters in this story, matter and antimatter. Think of them as perfect mirror twins. They have the same mass, they look the same, everything about them is identical, except for one tiny detail. Their electrical charge is flipped. An antiproton is just a proton with a negative charge. A positron is just an electron with a positive charge. Perfect opposites.
And this is where the plot really thickens. The theory says the Big Bang should have cooked up exactly equal amounts of both. But here's the catch. When matter and its antimatter twin meet, poof, they completely annihilate each other in a flash of pure energy. So, if they were created in perfect pairs, the entire universe should have just canceled itself out. Game over before it even started. And yet, here we are. The galaxies, the stars, you and me, we're basically the cosmic leftovers from that unbelievable battle. What this means is that something had to have tipped the scales. For every billion particles of antimatter, there must have been 1,000,000,001 particles of matter. That tiny 1 in a billion surplus is, well, it's everything, the whole universe. The question is, why?
For a long time, one of the wildest theories out there was that maybe gravity was the secret culprit. I mean, what if antimatter had anti-gravity? What if, instead of falling down like an apple, it fell up? This was the first major lead our cosmic detectives had to chase down.
So how in the world do you even test a crazy idea like that? Well, scientists at CERN built this incredibly clever experiment called Alpha G. It's amazing. First, they go through the ridiculously hard process of creating anti-hydrogen atoms. Then they trap them in this sort of magnetic bottle. And here's the genius part. They gently weaken the magnetic field at the top and the bottom and just let them go. They just watch to see which way they drift, up or down.
And the result? It was decisive. A whopping 80% of those little anti-atoms fell down. Yep, pulled by Earth's gravity just like a rock or a feather or you and me. It was a clear-cut answer. Antimatter definitely falls down.
And this is what's so cool about science, right? Most physicists, based on Einstein's theories, were pretty sure this was going to be the case. But you can't know. You never know for sure until you actually run the experiment and measure it. As one of the scientists, Jonathan Wirtle, said, you just have to do it because you can never be sure.
So, scratch that suspect off the list. The idea of anti-gravity, as awesome as it sounds, is officially busted. It's a dead end, which honestly just makes the whole mystery of why we exist even more puzzling.
Okay, so with gravity ruled out, the detectives at CERN turned their attention to a new lead. They started looking really closely at that perfect mirror between matter and antimatter, and began to wonder, what if it's not so perfect? What if there's a tiny, almost invisible crack in it?
This idea, this crack in the mirror, actually has a name. It's called CP violation. And it's a super subtle effect where a particle and its antiparticle don't behave as exact mirror images. Maybe they decay at slightly different rates. And that tiny asymmetry, well, that could be exactly the loophole that allowed matter to win the cosmic war.
And just recently, an experiment at CERN found the smoking gun. They observed CP violation with a certainty of 5.2 sigma. Now that's physicist speak for this is the real deal. To put it in perspective, the chance of this being a random fluke is less than 1 in 10 million. That's a discovery you can take to the bank. So, what did they actually find? Well, they watched this one specific particle, the beauty lambda baryon, decay over 80,000 times. And they saw that its matter and antimatter versions decayed in slightly different ways. The difference was tiny, just about 2.5%, but it was real. And it was the first time anyone had seen this effect in baryons, which is the family of particles that includes the very protons and neutrons that make us up. This is a big deal.
This discovery was a massive breakthrough, for sure. But it didn't close the case. Not even close. Now, the real challenge is to measure these tiny differences with even more mind-boggling precision. And to do that, scientists are basically building a whole new generation of forensic tools.
One of the most incredible new tools involves a little bit of quantum weirdness. Scientists have managed to create what's essentially the first ever antimatter qubit. Now, it's not for a quantum computer or anything like that. Instead, it's a hypersensitive probe that lets them measure the properties of an antiproton with a precision that's 10 to 100 times better than we've ever managed before.
And get this is something straight out of science fiction. They are literally learning how to put antimatter in a truck and drive it down the road. See, the problem is that CERN, the place where they make antimatter, is really noisy with magnetic interference. So this new project built a portable trap to carefully move the antiprotons to a much quieter lab, letting them make measurements that were just flat out impossible before.
So, after all that, where are we in this investigation? Well, we've ruled out our first suspect, we found some really compelling new clues, we're building incredible new tools to dig deeper, but the fundamental mystery, the why of it all, is still very, very much an open case.
And these findings are pushing scientists to consider some truly mind-bending possibilities. Even though the experiment showed that antimatter falls down here, some theories suggest there might be more to the story. To explain why there aren't huge galaxies made of antimatter out there, it's possible our universe has a sort of unseen, inverted twin, an anti-universe where antimatter is pushed away from our matter.
And here is the final, crucial twist. That CP violation we found, that amazing 5.2 sigma discovery, it's just not enough. It's way too small to explain the massive imbalance between matter and antimatter that we see all around us. The clues we have, they just don't solve the case. And that means there has to be something else out there. Some new physics, beyond anything we currently understand, that's waiting to be found.
So that leaves us with this one profound, lingering question. Is our entire existence just the result of a tiny, lucky flaw in the laws of physics? A glitch in the cosmic code? Or are these little asymmetries we're finding actually clues pointing to something way, way bigger, like a whole other universe hiding just beyond our view? The investigation, as they say, continues.